So statics type 6, forces and angle of friction. So we're going to have a look at the example 8.13 in your textbooks on page 148. And here we're given a rough plane is inclined at an angle A to the horizontal, where tan A is equal to a third. So we're going to start by working out our three ratios. So if tan A is equal to a third, and if I draw my right angle triangle, I have opposite and adjacent. And then by Pythagoras, I'll get the square root of 10 for my hypotenuse. So I can write down that sine A equals 1 over root 10 and cos A is equal to 3 over root 10. So that will come in useful in a few minutes. So if we're looking at the rest of the question, we're told there's a wooden block of weight W on the plane, and the block is also being pushed by a horizontal force of magnitude W also. We have to note here that the pushing force, pushing the block up, is not in parallel or perpendicular to the plane, so we're going to have to resolve that. And if we look at the weight, the downward force of the block, we can also see that that's going to have to be resolved as well. So at the end of the question, what we're trying to find is the coefficient of friction between the block and the plane, because it's a rough plane, so we have our friction. Now, if we look at the question, we're told that the block is on the point of moving. So if we just underline that, that's important, because on the point of moving means then that the limiting friction is called into play, so mu r, and the net forces then acting on the block are 0, because it's stationary, it's only on the point of moving. So that means that we can use our sum of the net forces is equal to 0, so the two principles of moments there. So we'll start by looking at resolving our weight first of all. So if we look at the diagram over here, we have weight acting down. So when I resolve it, again, parallel and perpendicular to the plane, we can see obviously that this is a right angle triangle here. So therefore we have 90 plus A plus this angle must give us 180, and therefore these two angles must be equal to 90, and therefore this one must be A, which makes this the opposite, and therefore when we resolve it, the one parallel to the plane is going to be W sine A, and the one perpendicular to the plane is going to be W cos A. So this is our weight resolved. And the next one we have to do is the applied force. So if we look at the applied force here, then what we want to do is again resolve it so that it's parallel and perpendicular to the plane. So again, parallel and perpendicular to the plane. And again, we have two parallel lines and a transversal. So therefore that makes these two angles alternate and these two angles alternate. So that makes that angle A. And therefore this would be the opposite. So it'll be W sine A, and this one will be W cos A, the adjacent side. Sorry, they're probably a bit small. So if I put that in on one diagram so we can see all of the up and down, left and right forces, I'm just going to use yellow here so we can see all of the actual forces, because obviously we need to make sure that when we resolve our forces they're in different colours. So if I do the weight on the block first, we had W cos A, but we know that cos A is 3 over root 10, so therefore there's going to be 3W over root 10, and then parallel. So this was sine because it was opposite the angle A there. So that was W sine A, so that's W over root 10. We then have our pushing force resolved, which was W cos A parallel to the plane. So 3W over root 10. And then perpendicular to the plane was sine, so that was W over root 10. Okay, sorry, they're really small. So let's look at our up and our down forces then. So if we look at the first row, we say our up forces equal our down forces. And therefore, our up is or. That equals our down force, which is W cos A. So we have W over root 10 plus 3W over root 10. So therefore, or is equal to 4W over root 10. And then our second one is our left forces equal our right forces. So in other words, the sum of our net forces is 0. And if I just go back to the diagram so you can see there, the left force was mu or plus W over root 10. And the left force there then is 3W over root 10. So we have W over root 10 plus mu or is equal to 3W over root 10. But we've already worked out what or is. It's 4W over root 10. So therefore, that is mu times or, which is 4W over root 10. And if I bring the W over root 10 over, that leaves us with 2W over root 10. And of course, the root 10 is gone, the W is gone, which leaves me with 4 mu equals 2. And therefore, mu equals 2 over 4, which is a half. And you are now finished the course. Yay! So I'm going to set you some exam questions to do. And I'm going to post the picture of these exam questions. And I'm going to get you to do 2005. And I'm going to get you to do 1999. Yeah, and 1999. So it's just the first part, A there. B is part of the question, but I'm not getting you to do that because obviously that's one we've already looked at, similar one. Okay, so that's 2005 question 7 and 1999 7A. And well done, you have officially finished Applied Maths.